My name is Marek Čuhák. I'll be speaking about engineering, and in my presentation I will mention 4 specific projects that we worked on with a geotechnician, geoengineer, Mr. Panuška, and also together with Konis, and I represent CUKON. We focus on of steel concrete structures, and we develop our own structures or our own software. So we use one central model, and geoengineer defined its own limiting conditions, and then there was a structural designer who designed loads, and they created then the actual design. The first project was the most interesting for us. We were asked to design ramps, like arrival ramps for Eurovia shopping center. We used the technology of injecting or jet injecting. You can see here that the layout. There were actually quite many of them. If we did it manually, we would not be ever possible to do it. Then we had cross sections from which we took information, and we use jet grouting, and we also took from the model the Z coordinate. It was not possible to do it manually, so we tried it differently. In AutoCAD, you have a function which allows you to extract data. We started with the bottom of the pit. Then every element has its own name or title and position, and then also diameter. So this way we were able to select the geometry and the positions, X and Y, the diameters of the jet grouting, and the titles of those components. So we were able to do it in this way, and we loaded it into Excel spreadsheet. We were missing also other components such as the Z coordinate and the depths. We used for that Visual Basic. We produced an Excel spreadsheet this way, and we could use that as an input to Revit. Then in Revit, we used a Dynamo feature or software in which you are able to create these little pieces of code, and what it means are little scripts. That means it loads the information from Excel and it creates individual components, and we use the components used by the contractor. And then we filled in all these parameters from the Excel spreadsheet, and then by a single click we generated all the components basically as a single click operation. So this is how it looked like. We didn't enter anything manual, everything was programmed. And the advantage of that is that we can eliminate any errors. And if we somehow made an error somewhere, we would see it visually as well. So this was the approach that we used also for others. We checked the diameters, length, etc. And then we could use the same thing for all the other components. Once we had the algorithm, then the job was done quite quickly. So this way we finished the entire project, and then the contractor took all the information and they were able to work with it, and then on the basis of that, they actually built it. So we didn't have to produce any drawings. There was approximately 500 components. If we did it manually, we would definitely made a mistake somewhere. Then we created an IFC file and we loaded the structure there so that the contractor can check any errors or collisions and check every component separately. So they would be able to click on any components and they would be able to check the parameters of each of them. So this is a very visual tool. It's a great aid. This is how it looked like. Okay, the next project. This was the existing structure where we had 2 underground stories already finished, and the investor wanted to change the overground structure, and they wanted to reinforce the existing foundations and create a new foundations, and they used the micropilots technology and also caps. We use non-linear strings, and together with the structural designer, they designed the final design. As you can see on the top left, the original piles with some added micro piles indicated by red. Then there was an analytical calculation model, then a geo-engineer entered that, and then all the other inputs. The result was something like this. We designed these anchor blocks, and it transferred a load from the upper structure to those micro piles. Okay, the next structure. It was a family house, and we were supposed to create the framework or pit boards or sheeting, and there was an equal straight edge. It was quite difficult to model this. What was interesting about this was that we took a component from the contractor where a slight deviation was allowed, and this way we were able to avoid any collisions, and this is how it looked like on site. As you can see, we did this sheeting under the crane, and then we built an abutment wall. Okay, and the last project that I want to mention, we needed to do some sheeting against the underground water. There was a pit 70 by 50 meters. There was a building in the vicinity which we need to anchor as well, and we used jet grouting and underground anchors. So again, in this case, we used the applications that we created, and we exported all the coordinates. This is how it looked like, how the project looked like, or the design, looking at the pit, and you can see how, for example, the neighboring building was reinforced. So to conclude, I would like to really highlight, since I work in Dynamo, I would like to recommend all of you to really learn this tool. because it is a very effective tool. Once you know how to use it, it saves you a lot of time, and there are just benefits to it. And then if you use Dynamo, then Revit, which is valuable on its own, in combination with Dynamo, it's a double. So thank you for your attention.